Good morning, everyone. Today we are going to introduce another topic related to function, which is called function composition. The first time we will see the title, you're probably wondering, what is composition? How does that work? Today we are going to discover the answer for these questions. So to introduce the topic, we are going to have two videos to answer all the questions we might have. So let's get started. First, before we introduce the lesson, let's have a quick warm-up. In this question, we have a graph of a function, and we are going to answer two part of questions here. You can pause the video and check how can you answer these questions, and later you can come back to see if you can have the same answer as mine. So this one, as we can see here, we know this is a graph g of x, and we need to answer g of 0 and g of 1. Based on the discussion we had before, we know, first of all, g of x is a function notation, which is y. And this one, g of 0, basically asking us when x equal to 0, what is y? All we need to do, looking for the values of x, which is on the x-axis, so 0 is here. So the graph is on the top part, so we go up 1. So this is our g of 0, which is 1. And continue. Next is asking us when x equal 1, what is y? So 1 is here. As we can see here, the graph is actually under x-axis, so we just go down 1, 2, this point. So this value is actually negative 2. So that's why the answer for g of 1 is negative 2. Second question can be a little bit tricky because second question is asking us, what are the x values make g of x as 1? Meaning, when x equal to what value, y is 1. So the first time you may say, oh, it's 0, because g of 0 is 1. This is based on what we discussed before. But let's go back to check the graph again. So to see this clearly, I'm going to erase whatever we have before to make it clear for you. So for this one, since y is 1, so let's check 1 here. And also to make it clear to us, when I draw a line here, all the values on this line, y is equal to 1, because this is 1, this is 1, this is 1. So all the y values, pay attention here, all the y values here are all 1. So all I need to check how many times this line intersects with this graph, then I know how many times the x value can make g of x is 1. So this is 0. So when x equal to 0, y is 1. Where is the second term? Is here. So, which is 1, 0, 1, 2, 3, 4. So meaning when x equal 4, y is also 1. Okay, so that's just a quick warm-up to review something we mentioned before about function notation. So let's discuss this topic, composition of function. That will be very interesting to discuss. So composition, you probably hear this word in different situations, like, and also sometimes when you see, probably you hear the word composite, or a lot of words starting with COM, like combine, those kind of things. So before, all this answer can be really related to function, to composition of function, or sometimes you hear the word saying function composition, they are the same thing. So before we start, I want to have a scenario to discuss laundry. I believe all of you, probably you don't do this by yourself, or but you definitely know what it is. So, and also for function, we always say, just for function, we always say input, and whatever we got here is output, right? So for example, a y equal to 3x plus 1, when x equal to 1, then y is 4. So this is input, and this is output. So this one is just quickly to remind you these two words here, because the next part we are going to use this two concepts here. So for function composition, the very first thing I want you to think about this. What is the input for this? If you consider you wash clothes, you get clothes cleaned, is a function, is something you need to work on, the input. Then what is input? Input is original thing you work on, which is dirty clothes. Oh, sorry. Dirty clothes, right? So this is the very first thing at the very beginning. This is dirty clothes we need to wash. And then the first part, the function is we need to wash. So this is the first function here. Then after you washed it, so what is output in this situation? Think about this. And some students probably already figured out the answer. Yes. Now we have wet, clean clothes. So that's the first thing, right? However, the laundry is not finished. Next thing, in order to have your clothes ready to put it on, to wear, what's the next thing we need to do? We need to dry the clothes. So you are going to put them in the dryer so you can have final output, which is dry, clean clothes, right? So this is very first input, the dirty clothes. You can see dry dirty clothes, but just consider it as dry clothes. And then we have very, very final output here. We have dry, clean clothes. And we have a two function. The first is wash. Remember, function is like something you work on. What are the things you work on, whatever the input you have? The first, you washed it and then you dry it. So you actually use two function work on that. This whole process is called a composition of function, which is also considered as function of function. And since we have a two function working together, that's why first you have f of x, and then you use g of x work on that. So that's why sometimes function composition is the symbol of that. This is your first function you are working on. This is the second function you are working on. And sometimes we use the little circle here to represent this symbol. So this one is the first function, and then you use the second one. So in the next video, we are going to introduce when in the abstract situation, for example, we see the two equation of function, then how do we complete function composition? See you soon in the next video.